Hi, welcome back to the Shuko Statistic Lecturing Series. We are in the unit of Introduction of Probabilities. And this is the second video about these lectures. On the first video, we covered the first two items. So we talk about the conditional probability. We also talk about what is the independent events. And today we're going to take a look at one of the very popular application about the conditional probability. We call this the Bayes Theorem here. Okay, so let's kind of review what we did here. So like we covered the previous video, we talked about the conditional probability and the definition of independence, those things. And we did 6 problems here. This is where the video one stopped. And today we're going to talk about this Bayes theory. That's what we call the theory number 4 here. And then we're going to work these 2 problems here. Okay, and before we work the problem, as always, I need to, give you a little lecture so you know what is the Bayes theory here. All right. Okay, so I'm going to go to the whiteboard and we will start here. Okay, so Bayes theory here. Okay, before we even look the formula, like a while ago I showed you on the last slide with the 2 problems here. So let me tell you what is the Bayes theory about. Okay, so I like to use the Venn diagram to show you the ideas here. Then we can write out the formulas here, right? So like in here, so this is my whole sample space. So I'm trying to use examples here. So in the sample space, in the whole sample space, you can divide it into several groups, right? So for example, this is like one group. This is the second groups here. And so for examples here, like today's hot topic is COVID-19. So one group you can say is obviously you have the symptoms, right? You are coughing and you have a hard time to breathe, and then you have an obvious symptom. Then the next group here, you can say I don't have any symptom at all. And then the third group, you can say, oh, I have been together with somebody with the symptom, and I do not social distance. So this is what this is what our group looks like here, right? Now inside this group, I have a special subgroup here. Okay, so this subgroup I said is A's here. Okay, so I said this is A. So what is the A's here? Right? So like in here we talk about, we said this is my group 1, group 2, group 3, right? So those are the 3 groups of the people with the COVID. And now the A is the COVID test. So I said A is test positive. So the A, I said this is we test, the test result show positive. Okay, so you can show positive with the people with the active system, the symptoms, right? So you can show positive with people has no symptom. You can show the positive with the people who have been together with the, the known, the people have the COVID. So you have these 3 groups you can show. So now if I said, what is the probability, I'm going to find, the people, be the positives, right? So I know for here, the positives here, in fact, you have what? You have 3 groups, right? So positive should be what? So the positive will be like this group's positive, add this group's positive, and add what? And add this group's positives, right? So you have 3 situations. They all can give you the positive. So the way you add it, then you will find what is the probability of getting positive. So for example, like here, I will mean find the A, right? So probability of A is the probability of the positive, right? So what is this one here? You have 3 branches. The first one is the B1. So the first you say, okay, in this sample size, what is the probability of the B1? All right? So of the B1, then times, given that, what is the accuracy of the test of the B1. So given that you test positive, then you add, if you are from the B2s here, then here, this is the given that is the B2s here. Then you say the B3s here, right? So if you be with somebody, you test for the positives here. So that's what we say, you can get the positive to test the results, right? So it's kind of like it makes sense here. So if you have the 3 groups of the people, and then like from the previous, what is the probability, if the people have the strong symptom, what is the chance, the result will show positive. And also if the people has no symptom, then what is the probability the result will show positive, right? So you add these 3. As you can see, this is one very, very common application. So for example, in other ones here, we typical doing that is, like for example, this is your sample space, and then we'll say we divide it into 2 groups, right? So this group is the woman get pregnant here. And then here, this woman is not pregnant here. Right? So now you are developing a pregnancy test, right? So this is what we call this a pregnancy test here. So the pregnancy test, so if it's pregnant, then what is the chance, sometimes the pregnancy test will not tell you name of pregnant, right? And sometimes if you are not pregnant here, the pregnancy test will give you false alarms here, right? So here is also, this is the positive here. So you can from here, you say, okay, what is the probability we'll get a positive result? So you use the pregnancy, percent of the woman pregnant times the percent of this test kits here will tell you it's a positive, right? If it's not pregnant, what is the percent of the woman is not pregnant here, then the result of the test will tell you, they are give you the false result here, right? That's why you will see, that's how do I find the positives here. That's what is the Bayesian series here. So that's why in general, if you look at the formulas here, this is the formula. So we say PA is equal to, right, summation I from 1 to K, and this is the PBI times the PBI time given A here. That is what is the Bayesian series about. And like I say, if you just look at this formula, that's not ring the bell, it seems it's not obvious. But if you take a look at those examples, so basically the BI, so what is the BI? BI is how many groups in your sample space, right? So this is the sample space. So here can be 1 BI, so your sample space could have the, right? So the sample space can be divided into 4 groups. Then you have some type of the criteria here, right? That's what we call this A. So depends on what you define those criteria. Then you can find the probability of the A's here by doing each sub one, under the B1, under the B2, under the B3, under the B4. Okay, you got that? Okay, so now let's take a look at some problem. I think it will help you to understand that. Okay, so let's say a rare but very serious disease has been found in the 0.01% of the population. A test has been developed that will be positive for 98% of those who have the disease, and be positive for only 3% of those who do not have disease. All right, so find the probability. If a person test is positive, does not have the disease. All right. So basically, you want to find what? Okay, so let's, so in here you say you want to find in here the person test positive, right? Test positive, that means given the condition, I got the test is positive, has no disease, right? So this is what? This is no disease. Given that my test is what? My test is positive, right? So that's what is this statement is here. The probability a person tests as positive, but it's not have a disease. All right. So now I can use my conditional probability. I will say this is a positive. Now what is the top here we talked before? Is A and B, right? So that means no disease. And what is the and? Intersect, right? And positive. Okay. Okay, so now let's see how do we do that. Okay, so in here, typical when we do this type of problem, if you do a tree diagram, it will be easier. So in here, you will say, this is the population, the people have a disease. So it's a 0.01%, right? So this is a 0.0001, right? Okay, so then this branch here, this is no disease. What is the, if it's a 0.0001 have a disease, so what is a no disease? It's 0.9999, right? So it has no disease. Okay, so this is a disease branches here. Now after disease, they said, hey, I have this test, right? So this test, I have a positive. What is the probability if you have the disease, test positive? 0.98, correct? And what is the probability you get a negative result? That means if you have the disease, I cannot detect, then it will be 0.02, correct? So now the same way is here. If it is no disease, then it is showing 3% of them will be positive. So that means this is a positive. What is the percent? 0.03. Then it will show you negative. What is the percent here? Will be 0.97, right? So that's how do we do that. So now I want to see the positive, right? So if you take a look at positive, I really have two branches here. This is the test result that will give me positive. And this is the test result that will give me positives, right? Okay, so now I know then my, so the positives here is you have to be 0.0001 times 0.98, right? You have to have a disease first, and then you test the positive. So it's a condition. So positive given that. So this is the conditions, right? Then plus, or you don't have a disease, 0.9999 times 0.03, correct? So that what is here? What is down here for here? Like what is here? This is the probability you test positive. Correct? Okay, now let's say, what is the probability? So it's no disease and positive. So where is no disease and positive? What is my numerator is here, right? No disease and positive. So will be what? 9999 and positive is 0.03 here. All right. Okay, so if you put this into a calculator, you will get this is 0.997. Okay. That means this test really is not very good. Okay, because you test positive, in fact, it's no disease. You do not get a disease. It's so high, it's 0.997. That means you'll get so many false alarms here, right? So this one's here. Is I said, if you know, so if a person tests positive, what is the chance this person have no disease? 99.7%. So that means this test is not a good test. It gives you so many false alarms here. Okay, now let's take a look at the problem number 8 here, right? So let's say it is known from the experience, 60% of all the labor and management dispute over wage, 15 over working conditions, and 25 are over fringe issues. And 45 of the dispute over the wages are resolved without a strike. 70% resolved from the working condition without a strike. And the 40% dispute of the fringe issues resolved without a strike. What is the probability to result without a strike? Okay, so here the first thing is here we say, okay, I have 3 types of the dispute, correct? Okay, so 60%, this is what? This is wages, right? So this is 60%. So it's 0.6. What is the second one here? So this is working conditions, right? Working conditions. So what is the percent here? 15%, so it's 0.15. And then what is the last one? Is fringe issues here. What is the percent here? 0.25 here, right? So this is my conditions, right? So now what is the, the strike? Okay, so this is a strike and this is no strike here. Okay, if it's over the wage issues and 45%, so resolve without a strike, so it's 0.45, correct? Okay, so 0.45. So here with strikes, 0.55. Working conditions here, this is a strike. This is no strike, right? The working conditions, 70% of them resolved without a strike. So it's 0.757. So with strike, or 0.3. Okay, so the same things here. This is a strike. And this is no strike with fringe issues. What is that? 40% issue resolved without a strike. So this is 0.4. And also with strike, it's 0.60, right? So the problem we want you to find without a strike. So without a strike, so let's see how many branches I have. This is the one branch without a strike. This is the branch without a strike, and then this is the branch without a strike, right? So I have 3 branches here. So the probability without strike. So, okay, so the first branch is given this condition. So it's a 0.6 by the multiplication rule, 0.45. Then plus the working condition is 0.15 plus 0.7, right? And then the fringe issues is 0.25 times 0.4, right? So this is 25. And the 0.25 times 0.4. So if you 0.475, that means it's about like 47.5% of the all the issues, you will end up without strikes here. All right, so that's what is the without strikes probability, and this is what we call this the Bayesian applications here, right? So that's why if you use this tree diagram to do this type of the problems, it's pretty easy. So you just need to draw it and then read the problem carefully to see which branches they meet. All right. Okay, that's it. This is a very short video, and I hope that you understand that. And like I said, this is very, very common application, and you can, almost like you can experience that in many different areas, especially in the medical area, when you test new drug, those things, right? So it is very, very useful application. Okay, so that's it, and I'm very glad to talk to you about this, and I think this, finished this unit here. Okay, so looking forward to talk to you in the next units. Have a good day, and don't forget to subscribe the channel if you like it, so you will get a notification whenever a new video, is posted. Okay, bye. Have a good day.